Hi there! In today's video, I am trying to make C and Rust as fast as PHP. Let me explain. So recently I created my first ever C program, which is this CSV find tool, which works this way. I can run CSV find and I can give it a name of a CSV file. In this case, products.csv. And then I can give it a search term like Apple. And then I can search for all the products in products.csv that contain the word Apple. And it is case insensitive. Now I can also specify a column. So I can say something like $12.99 price. And then it will return everything that is $12.99 price. And it works just fine. Now after I made this, I decided to check, hey, how much faster is this than PHP? Because normally I write PHP and now I'm trying to learn C and C is supposed to be faster. So I want to see how much faster is this. So I created a PHP version of this code, which is a lot simpler actually. It's just 50 lines of code and the C version is around 100 lines of code. Now obviously C is going to be a bit longer. So I added a timer here to check how long it takes to run this program. So if I run PHP CSV find.php and I give it the products.csv and I say Apple, then it works just like the C version and I get the time here in seconds. So then I went to my C code and I did the same timing in this one. So let's try to see if I remember how to do that. So I have to include time and then in the main I have to say clock t start equals clock. And then I have to go down here and I have to say clock t end equals clock. And then I have to do double time equals, and now here I have to do some weird casting into double. So I have to say double and I have to put here end minus start and I have to divide this by clocks per second. And then I can do printf float, new line and time. So now if I run this, so I compile this again, gcc o csv find csv find.c. And then if I run this again and I use Apple, then it's 0.00114 and the PHP version is 0.0017. So far C is in fact faster. Now of course this is such a low number that it's difficult to test. So I wrote this CSV copy script. Since I'm trying to learn C, then I wrote this code in C that copies the contents of the products file 10,000 times. So I created this copy file contents function that takes the input file and the output file and then a buffer for the line and then reads a line from the input file to the buffer and then writes it to the output file. And then I have this write x times, which takes the input file and a number of times to write and then the output file and the line buffer. And then it loops times and then it runs copy file contents from the input file to the output file. And then it rewinds the input file back to the start and does this again and again. And then here I just call write x times file 10,000 output file. So this should copy the products.csv into output.csv 10,000 times. So let's compile this gcc o csv copy.c. And then let's run CSV copy and it copied everything. So now if I open this output and hope that VS Code doesn't crash from 110,000 lines, okay. And then I go down here to the last line and I change ThinkPad to WinkPad. So now I should have a word here that is not occurring in the rest of the file. So now we can try to search for that. So let's do PHP CSV find.php and output.csv and WinkPad. So this took 289 milliseconds. Okay, let's run CSV find output WinkPad. This took 377 milliseconds. What? Why is C slower than PHP? What is going on? So at first I thought maybe there's something wrong with my timing, because PHP is of course an interpreted language. So I'm guessing that the time begins when the PHP interpreter actually starts to interpret the code. So there might be some overhead from the actual PHP interpreter. So then I wrote another PHP code that runs a command a specified amount of times and then times that. So now I should be, if I'm not completely mistaken, I should be able to actually time the whole execution time of the script. And then I test it by running it 5 times for each of these. And I have actually written a Rust version as well, which is over here. So let's see which one of these is the fastest. So let's run php test.php. PHP is 900 milliseconds, C is 1.1 seconds, and Rust is 1.25 seconds. What is going on here? Why are these lower level languages slower than PHP? Okay, let's go take a look at our CSV find file. So of course, this is my first ever C program, so there probably is many things that are wrong with it. But really what it comes down to is this to lowercase function. Now I created this myself, so I get the length of the text that we want to convert to lowercase. And then I loop through all of the letters of that text and I convert them to lowercase. Now this seems pretty straightforward, like that's what you have to do, okay? And then when I am comparing, for example here, the current header to the header name, which is the header that we want to search from, I'm converting both of these to lowercase here in this while loop. And in fact, it is in 2 while loops because we are looping through the lines and then we are looping through the columns of the CSV. So in fact, what would be better is if we moved these out of it, because we don't have to do this every time. So the current header comes from the header buffer, which we populate on the first line. So we can actually convert to lowercase the header when we save it to the buffer. And then the header name, which comes from the command line arguments, we can of course convert that already to lowercase up here, where we get it. And what else? Now here we are checking if the token, which is the current column, if the current column includes the search term, and both of these lowercase, so that it is case insensitive, then we print the line. But again, we don't have to convert the search term to lowercase every time. So let's move this up here as well. So when we get it from the arguments, we convert it to lowercase. Now here is a problem. We have to convert the token to lowercase because it is different every time. But let's see if this is any faster. So I will compile this. gcc o csv find.c. And then let's run our test.php again. Okay, well, we are at 1.02 now, when before we were at 1.17. So it is faster, but it's still slower than PHP. Now it's marginally slower. Let's run this one more time. Yes, it's almost the same, but it's still slower. Now if you take a look at the CSV find.php, here what we are doing is we are actually not calling str to lower anywhere. We are using str_i_pos, which is a case insensitive version of the first occurrence of a string. Now in C we do not have str or str_i_pos. So of course the first thing I did is I went to Google and I asked case insensitive str in C, and then we got this StackOverflow page. So let's open this and see what we have here. Okay, we have here an answer. From the man page of strstr, there is str case str. Now, if I would have read this manual page completely, then I would have found the answer. But what I did is I check, okay, it's str case str, so let's do that. Let's say str case str, and let's save this and let's run it. Compile it first. What? We got a warning. Okay. Did you mean str case cmp? What? So then again, without reading the rest of the documentation, I scrolled down and here someone says, my man page says the str function conforms to C89 and C99. The str case str function is a non-standard extension. Okay. And someone said, it's not in my Visual C library. So I thought, okay, this probably needs some sort of library to be installed or something fancy that I don't know how to do. I abandoned this idea and I scrolled down even more. And then someone said here, while some compiler C libraries include extensions with case-insensitive versions of the standard string functions, such as GNU's strcase_str, the naming of such functions is not standardized even when included. One way of overcoming the lack of standard implementation is of course to implement your own. Now I thought, okay, well, let me copy this code then. I wasn't really happy about copying randomly some code, but let's see if this actually works. So paste this here, and then we can use str. So let's change this to str. And of course we can remove the two lowercase, which I should have removed already in the previous example. So now if we try to compile this, it actually compiles. And then let's run our test.php. What? 2.5 seconds? This is slower than before. What? This is not a good idea. So then I went back to Stack Overflow and I scrolled down a bit. And then someone else had made their version. So let's copy this one and see if this works. So paste it in here and let's use str3. So put it there and then compile this and then run the test. And again, it is 2 seconds. It's faster, but it's still 2 seconds. And it's slower than PHP. Okay, I went back. And here someone says, here is a slightly more efficient version. So let's copy this and see if finally this will work. So I pasted it in here, and this one is called str4. And let's put it here, and let's compile it, and let's run the test and see what happens. Okay, now we are actually faster than PHP. Let's run this one more time. Uh-oh, now we are slower. So it is not actually faster. Sometimes it's faster, sometimes it's slower. But really what I'm looking for is it should be a lot faster than PHP. So let's go back to the original version. So what is so slow about this? Well, two lowercase has to loop through each of the letters of the token. So we have to do this for each of the letters of each of the lines. But now actually you don't have to do this, because if you find the word that you're looking for, you can stop. You don't have to convert the rest of the text into lowercase. So before I show you the actual solution for this, if you haven't guessed it already, then let's try to create our own str. So we will remove this two lowercase from here, and let's go up here and create a new one. Now I will use integer as the return value. This will just be 1 or 0, whether it was found or not, because honestly I don't know how to return the character pointer from this, and I don't need it. Let's call it str, and we will take a character pointer to a haystack and character pointer to a needle. And then what should we do here? We should loop through each of the letters in the haystack and compare them to the first letter of the needle. And then if it's the same, then we should change to comparing to the next letter of the needle. And if we find that, then we move again to the next letter of the needle. And if it is not the same, then we have to jump back to the first letter of the needle. So let's define first integer needle position is 0. And then let's say that the integer length will be strlen of haystack. And then let's do a for loop. For int I is 0, I smaller than the length, I plus plus. We should then check that if the two lower of the haystack index I is the same as the two lower of the needle index needle position, then we will add to the needle position. So we will say needle position plus plus. Otherwise, we set the needle position back to 0. And then we have to detect when we come to the end of the needle. So if we come to the end of the needle, that means that all of the letters matched. So then we found a match. So if the needle position, if the needle of index needle position is a null character, because every string ends in a null character, then we return 1, because here we incremented already, so this will be the next letter. So if the next letter would be a null character, then we found a match. And if we go all the way to the end, then we return 0. So let's see if this still works. So we have str, but we change from null to 0. And let's then compile this. gcc o csvfind.c. And it compiled. So let's actually first run this and see that it produces the right result. CSV find output wink pad. Yes, but it's very slow. This is 300 milliseconds to run this, whereas the PHP version is csvfind.php output wink pad 200 milliseconds. So how can we optimize this function? Let's go back here. Now the strlen function is basically already a loop because we have to loop through all the letters of the haystack to calculate the length of the haystack. So can we omit this somehow? Well, one thing that you saw in one of the examples from Stack Overflow, you can do something like this. You can omit this index from here and this one as well. And here you can just say that pointer to haystack plus plus. So apparently what this does is that it increments the pointer to the haystack to the next letter. So then you don't have to use any indices. And then we can say, while this one is not a null character, then we continue. So this should automatically loop through the haystack, and we don't have to get the length of the haystack separately. And then what we can do is we can just say to lower, and I don't remember if I have to put the pointer here or not. I think it was this way. So now if we save this, this should still do the same thing. So if I compile this and I run it, it is seemingly slower, but it still works. But it didn't really do anything. Perhaps the C compiler optimized something. So nothing happened. Now what else can we do? Well, one other thing, again from Stack Overflow, is that you don't have to convert to lowercase the first letter of the needle every time. Because at first you're looking for the first letter, but you don't have to convert it every time. So what we can do is we can set this here as int needle first lower is going to be this. And actually we will get the 0th element, or in fact we can probably do this, the pointer to the needle. And we don't need to have the needle position anymore. And then what we will do here is we will say if to lower of the haystack, the current position in the haystack, is the needle first lower. We then loop through the rest of the needle characters. So we will do a for loop, and we will say int I equals 0, and we will omit the rest of these parameters. And then what we will do is we will do this. We will move this statement inside this loop, and then we will do this. If the lowercase version of the haystack index I equals the lowercase of the needle plus plus I, so this will actually increment it here already. So this will be the first, the index 1 of the needle. So the second letter, because we checked the first letter here already. And I believe that when we use this syntax, the index I will be actually from the already moved pointer position. So this is not from the start of the haystack, it is from the start of the current position of the pointer. So we can actually flip this around. We can say, if they are not the same, then we will break. So we will break here, okay? But then we again have to check if we are in the end of the needle. So we move this up here. And in fact, I will move this plus plus I over here. So we increment it here already. And this will be just I, because it is incremented here already. So if we came to the end of the needle, then we return 1. And otherwise, we return 0. So this seemingly is more complicated, but we are not converting the first letter of the needle to lowercase every time. So it should be faster. So let's see, is it fast? And more importantly, is it faster than PHP? So let's compile this and let's run it. And look at this. We have 250 milliseconds. So it is faster. But let's compare it with PHP. So let's do PHP test.php. 920. It is still not faster than PHP, but it is faster than before. Okay, now what can we do? Now here is the solution to this problem. If I would have read this original post here from the man page, I would have known the solution. Can you see the solution? Now I also could have done this. If I go and remove my own implementation str, and I change this to str case str, and this to null. And if I then try to compile this, I get this warning. If I now Google this warning, and I go to how do I use str case str, and I scroll to the answer, here it says it very clearly. As specified in the corresponding man page, since str case str is a non-standard extension, you must define GNU source before any include. So here is the solution. I have to copy this and I have to define this magical constant up here. And then if I compile this, I get no errors. And now if I run this program, it is 150 milliseconds. So now finally, if I go to test.php and I run this, it is faster. So the C version is 600 milliseconds and the PHP version is 900 milliseconds. So now I'm finally happy. And it seems to be the same if I run it again. Now, Rust. What is going on with Rust? Now, here's my Rust code. Let's go look through the Rust code. By the way, even if I don't add this GNU source here and I compile it and I run it, it works. It just gives a warning. But I didn't try to run it actually after compiling it. So it would have worked originally, and I saved like hours, literally hours. I tried to find out how to do this, and I tried to find out how to create my own function. Let me know in the comments, is there a way to create your own str function in C that would be faster than the str case? And why is this faster? What different thing is it doing to make it faster than C, or faster than implementing it in C yourself? How is this implemented? I want to know. But anyway, let's get to our Rust code. So again, I'm a complete noob in Rust and C, so it might not come as a surprise that my code is slower than PHP. Now with C, of course, that was a very stupid mistake that I had. But in Rust, I have not found the solution for this. So basically this works similarly to the other script. So we get the time now from instant now. We get the arguments, we get the input file, we get the search term, and then we read the input file, and then we get the header name. I'm not very proud of this line of code because I have this string new in here. So it will return an empty string or the header name that was given in lowercase. I would like it to return none or the header name in lowercase, but I couldn't figure out how to do it, at least in one line or like in a simple way. And then I set the headers as a vector, and then I read the file. I get the lines of the file and I enumerate over them so that I can get the line number and the line. And I use for each here. Now it seems that you can loop through the lines of a file in Rust in many different ways. So this is just one way. But Rust is supposed to have zero cost abstractions, so it shouldn't matter, should it? Anyway, I'm not sure if this is the thing that is making it slower or not. Then we read the line. Then we set print line to false. And then we split the line by the comma and we again enumerate and we get the column number and the column. And if the line number is 0, then we add the column trimmed to the headers. And then we get the current header. And then here we just check that if we actually got a header name in the arguments and there is a header for this current column and the header name that we are searching for is not the same as the current header we are on, 2 lowercase, then we continue. And then here, if we are on the first line, which is the header line, we print the line, or if the column, 2 lowercase, contains the search term. Now, I believe that we have the same problem here. So this 2 lowercase is the culprit. I could not find something like contains case insensitive or CI or something like this. There seems to not be something like this. And I wonder why. And I just don't know how to do this. So please, if you know how to do this in Rust faster than PHP, then let me know in the comment. I really want to know. Because if you try to Google this, you just can't find an answer. Like if I say Rust string contains case insensitive. We get case insensitive string matching in Rust. So we open this and the first answer is 2 lowercase and then matches. Now I'm not using matches, but I don't think that matters. It's just this 2 lowercase is too slow in a loop. And then they suggest regex, but I tried regex too, but it was a lot slower. And obviously it should be a lot slower. So I really don't know how to solve this problem in Rust. Now we can try to remove this and make it non-case insensitive. So that would be case sensitive. And then if I go to my Rust CSV find and I do cargo build release. And then I go back and I say php test.php. Then now Rust at least is faster than PHP, but it is not case insensitive. So let's actually change this to be case sensitive as well. And then run this. So let's see if it's faster now. Yes, it is faster in the case sensitive version of PHP, but not in the case intent. So I hope you enjoyed this video and I hope you learned something. And please do let me know in the comments what is the way to do this faster in Rust. And do you have an even better way to do this in C? And why is str case str faster than implementing your own function? And make sure to subscribe to my channel so you get more videos like this in the future. Thanks for watching and I will see you in the next one.